Take two. Good morning, good afternoon, wherever you may be in the day. Thank you as always for choosing to make chemistry part of your day. It is my distinct pleasure to introduce one of my best friends in the world, the periodic table, or PT for short. Here is a caricature of the periodic table. I have just a sketch of it so we can talk about some basic elements. Starting with, why is it called the periodic table? Well, we see the same types of patterns over and over and over again. So that's the periodicity of it, if you will. And what is that period of repeating? Well, it's each row. So each row is a period. So the rows of the periodic table are a period. And then the columns are a family. Just like within a family, there's shared characteristics. If you saw my brother, we both have the same color eyes, hair, relatively the same height, build, those types of aspects. If you saw my two sons, you would know they're related to each other. Very similar chin structure, things like that. Coloring of the hair, eyes, skin, all of those traits. Okay, so same thing with the chemicals. Magnesium and calcium have very similar chemistry. They both react semi-violently with water. They both form positive 2 charges. They're both metals. They're both conductors. Same color, those types of issues. So fairly similar properties, and you see that throughout them. They're not identical, just like you and your siblings and parents are not identical, but you do have shared characteristics. So up and down family, left to right, period. The 2 tall parts are called the main group. The low part that transitions between the 2 tall parts is called the transition metals. And sometimes these ones at the bottom are called the intertransition metals. So the transition metals are this low part, and then the tall parts are the main group elements. Anything else? Most of the family names I will not use. I'll use the more modern names and not the traditional names. So the first column I'll call family 1. The second column I'll call family 2. The third one I'll call family 3, and so on and so forth. And over here we get to 13, 14, 15, etc., etc. I'll use that naming structure. I think it's less confusing than some of the more traditional structures, with 2 exceptions. I do like to, for the last column, call them the noble gases. Everybody calls them the noble gases. You should know what that means. And they're called the noble gases because, much like the nobility, for example, in Florence, the nobility built an entire city above the ground so that the nobles never had to walk in the same place as the regular folk. So same thing here with the elements. They don't mix with the other elements on the periodic table. They stay alone. So they don't react. So they just, in some ways, they're not that interesting because of it, although they do have some good uses because of that, but they're very unreactive, or inert. Now right next to them is a very reactive class called halogens. And that term gets used a lot too, so I do want you exposed to that idea. So these are the halogens, fluorine, chlorine, bromine, iodine. That would be the halogens. At the very end are the noble gases, and the rest of them I'll just go by number. And then the other thing to point out is if we look at barium, it goes from 56 to 71. We didn't lose our minds. We didn't lose a whole bunch of elements. They're down here at the bottom. The lanthanides and the actinides, for very practical reasons, otherwise the periodic table won't fit on a sheet of paper, got chunked out and they're down at the bottom. Most periodic tables have a star or some kind of symbol here designating that you should look down for the rest of the periodic table. And then the other important thing here is this lightning bolt, crooked line, whatever you want to call this. And this is going to be a real divisor. You have to know this to be able to do much of anything in chemistry. That's the bad news. The good news is it's a very simple thing. So, to the left, titanium, iron, nickel, copper, zinc. These are all things you already think of as metals. To the left are the metals. If you ever get confused, just look. Hey, iron's over here. I know iron's a metal. And then the other things are the nonmetals. So what does that look like? In character format, again, here's our periodic table, the tall parts of the main groups. I want you to think of hydrogen as really being over here. It's much more like the nonmetals than it is a metal. How do I know that? Well, hydrogen is a colorless gas, and metals tend to be silver, shiny, solids, moldable, spinnable into wires, or ductile, positive charges, high melting points and boiling points, conduct electricity and heat. All of those things that hydrogen does not. Hydrogen is pretty much an insulator. It has an extremely low melting point and boiling point. It's a gas at almost any temperature on Earth. It is brittle. If you were to get the solid of it, it'd be, think ice cubes. You can break it. You're not going to turn it into a shield or a fork or something like that. And there are And I will acknowledge there are some elements that are not cleanly metals and not cleanly nonmetals. They might be silver, but they got relatively low melting points and boiling points. They're semiconductors, or they're colored. Yeah, that's another thing. They tend to be colored. Or these tend to be silver. But I'm going to ignore them for the sake of simplicity in Chem 101. I understand things like boron are in between property-wise, and we might call it a semi-metal or a metalloid. But for the sake of simplicity, you're to the left, you're the metal. You're to the right, you're the non-metal, and we're not going to worry about those in-between cases. We have enough to study this semester without making extra work for ourselves. Let's take out one box out of the periodic table. This is each box is an element, and what makes an element an element? Well, it's the atomic number. And that atomic number is the whole number. It's a smaller number, sometimes on top, sometimes on the bottom. And it's how many protons are in each atom. And that's what defines an element. What makes an element is the number of protons. So every lithium atom in the universe has 3 protons. Now the other number is your atomic mass, and that's the sum of the protons and the neutrons. And you might ask, well, how do I get 6.9 of something? Well, you don't. It's an average. So some of them are 7, some of them are 6. Obviously, there's more 7s than 6s since that number is closer to 7, but it's an average. So what do we call that when they're different? We call those isotopes, where it's the same element, meaning it has the exact same number of protons, but it has a different mass, meaning it has a different number of neutrons. So what would that look like? So like I said, lithium comes in 2 isotopes, lithium-7, lithium-6. They're both lithium. We can go to the periodic table, see that's number 3, and know that there's 3 protons. If we subtract the protons from the mass, we're left with the neutrons. And this might be a little bit hard to see, but 7 minus 3 is 4 neutrons, and 6 minus 3 is 3 neutrons. So indeed, 2 different isotopes based off the number of neutrons. And that's what makes an isotope an isotope. And we are all done with this, and have a wonderful day, and thank you for your time and attention.